Dear students, now we are going to see the subject linear integrated circuit. The subject code is EC3451. Under that, the topic is applications of PLL. On completion of this applications of PLL, the students can able to know the different area where the PLL is used. The PLL can be used as a AM detector or AM demodulator. The PLL is locked to a carrier frequency of the incoming AM signal. Once locked, the output frequency of the VCO is same as the carrier frequency, but it is in unmodulated form. So the VCO output is always 90° out of phase with the incoming AM signal under locked condition. So the AM input signal is shifted by 90° before fed to the amplifier or the multiplier. The two signals applied to the multipliers are namely amplitude modulated signal and a carrier signal generated in the PLL are now in phase. So the output of the multiplier is fed to the low pass filter for filtering the high frequency component. A PLL AM detector exhibits a high degree of selectivity and noise immunity, which is not possible with the convenient peak detector type AM modulators. FM detection. The block diagram of FM detection or the FM demodulator is shown in figure. The voltage controlled oscillator frequency follow the instantaneous frequency of the input signal. The filtered error voltage which control the VCO and maintain the lock with the input signal is the demodulated FM output. The VCO transfer characteristics determine the linearity of the demodulated output. Since the voltage control oscillator used in the PLL IC is highly linear, it is possible to realize the highly linear FM modulators. So the FSK. So in FM modulation, the signal f of t is given by f of t equal to carrier signal plus change in carrier signal del fc into sine omega t. The PLL can also be used as a frequency shift keying modulation and demodulation. In FSK modulation and demodulation, the block diagram is shown in figure. Here, the FSK technique is used in digital communication. Here the binary data is transmitted by means of the carrier frequency, and this signal uses two logic 0 and logic 1. These two signals are represented by two different frequencies. This type of data transmission is called frequency shift keying. In this transmission, on receiving end, two carrier frequencies are converted into 1 and 0 to the original data. This is FSK demodulation. The symmetric arrangement of FSK demodulation using PLL is shown in figure. This PLL is designed to remain a lock with the FSK signal for both frequency F1 and F2. So the voltage controlled oscillator generate the control voltage that is fed to the comparator. So Vf1 is given by F1 minus F0 divided by K0. F0 is the VCO output signal. F1 is the phase detector output. Similarly, Vf2 is equal to F2 minus F0 by K0. So the difference between two control voltages given by del F, that is V2 minus Vf1, that is equal to F2 minus F0 by K0 minus F1 minus F0 by K0. So K0 is the voltage through frequency transfer coefficient of the voltage controlled oscillator. So the reference voltage for the comparator is derived from the low pass filter used in the circuit diagram. So and its output is the midway between the frequency Vf1 and Vf2. Therefore, Vf1 and Vf2 of the comparator gives an output V0 and gives an output 0 and 1 respectively. PLL can also be used as a frequency synthesizer. So in the frequency synthesizer, it can produce a precise frequency that is derived for a stable crystal controlled oscillator. The figure shows the frequency synthesizer. Here the second input signal to the phase detector is fed by the output of the voltage controlled oscillator. A divide by N counter is inserted in the loop and the output is given by Fd is equal to F naught by N. F naught is the output frequency of the voltage controlled oscillator. So divide by N counter is realized with the programmable divider and therefore possible to achieve a multiple of reference frequency. By using harmonic locking, the frequency synthesizing can also be obtained. The locking is achieved with the harmonic reference signal. So the voltage controlled oscillator frequency is set to the multiple of input reference frequency. This is the drawback of this frequency synthesizer, and this method the lock range reduces when successively a high and weaker harmonics are used for locking. The possible questions in F is find the frequency shift in FSK generator. In frequency shift, that is the difference between the FS signal 1070 and 1270. That means the difference is 200 Hz. Thank you.